Stoichiometry is from the Greek words stoichion meaning element and metron meaning to measure. It's the calculation of the amounts of substances involved in chemical reactions. What information does a chemical equation give you? Well, you'd be surprised. Like the periodic table, a lot of it is just inferred. So let's take a look at an equation. All right, here we have an equation showing a nitrogen and hydrogen gases reacting to produce ammonia gas. And it's balanced. The mole ratio is 1 to 3 to 2. Now let's just see exactly what these numbers really mean. They could mean 1 molecule of nitrogen combines with 3 molecules of hydrogen to produce 2 molecules of ammonia. That's simply true. But it could also mean that it could be Avogadro's number of molecules in a 1 to 3 to 2 ratio as well. So whether we have 1 to 3 to 2 molecules, or 10 to 30 to 20, or 1 million to 3 million to 2 million, it's the ratio that's important. Now once we have Avogadro's number, of course, we can replace that with moles. Now I put this in a different color because this is important. We're going to be using the mole ratio between substances in a chemical reaction. So there's all sorts of ratios we can get from this. So we have a ratio directly in terms of moles. 1 mole of nitrogen requires 3 moles of hydrogen to react completely. And when that happens, you wind up making 2 moles of ammonia. Because it's moles, we could replace that with mass. All we have to do is take the number of moles and multiply it by the molar mass of the substance. So the molar mass of N2 is 28 grams, H2 2 grams, and NH3 is 17 grams. And we could continue out with this and come up with the total mass amounts, but as we're going to see, it's really not necessary. So I like to use the 2 lines in red from almost all the problems that we're going to do in the rest of the chapter. So now here's an example of a chemical reaction between nitrogen and hydrogen again, making ammonia. Here's our balanced equation. And if you read the problem, we want to come up with the given information and what exactly are we looking for. So we were given 4.5 moles of nitrogen, and we're looking for moles of ammonia. And what we need is a mole ratio from the equation. We can see that's a 1 to 3 mole ratio, 1 to 2, 2 being the ammonia. So I'm going to get my conversion factor from the equation, and then it's just setting up the solution. So I'm going to take my 4.5 moles of nitrogen and multiply it by that mole ratio from the equation, and cancel out the units, and I get my answer. And you notice 3 significant figures in my answer because I started with 3 significant figures in the given amount. Very simple question. So we're going to get all sorts of conversion factors directly from the balanced equation. Now here's another question involving stoichiometry. How many moles of water can be produced by reacting 6.5 moles of oxygen completely? Here's our equation, and then here's our question. So we're going to need the mole ratio between oxygen and water to solve this question. And we get that from looking up above at the equation, and we see that it's a 1 to 2 mole ratio. Then we set up the solution. You notice we can cancel out oxygen and wind up with an answer of 13 moles of water. What could be simpler? Now here's a question involving grams, which is more common. How many grams of ammonia can be produced by reacting 2.30 moles of nitrogen gas? So now we have a combination of moles and grams here. Again, first thing I want to do is write my question. Here's the given information. Here's what I'm looking for. Now I'm going to need conversion factors to solve this one. There's going to be more than one conversion factor. So I want to plan this out. So I'm going to find the number of moles of ammonia that I can make, and then I'm going to change moles of ammonia to grams. So I need 2 conversion factors, and here they are. 1 mole of N2 to 2 moles of ammonia, and that's from the balanced equation again. And 1 mole of ammonia weighs 17 grams. That's just a sum of the atomic masses. So I'm going to be starting then with my solution with the 2.30 moles of N2, and then setting up my conversion factors. So you notice, starting with moles of N2, First thing I do is figure out moles of ammonia, cancel out my units, and then I change moles to grams. So now I had two conversion factors necessary to solve this one. Right, let's take a look at another question, very similar. Now I'd like you to pause at this point and try to finish it off yourself. So here's the balance equation, here's what we're given, and here's what we're looking for. So pause the slide now, give it a try. Come on back when you're ready and see the solution. Okay, here's the solution now. We're going to go from moles of methane to moles of CO2, and then we're going to convert that to grams. Here's my two conversion factors. My first one, moles of methane to moles of CO2 is 1-to-1 mole ratio. You can see that right up here, 1-to-1. And 44 grams per mole is the molar mass of CO2. Now here's my setup. You notice I can cancel out moles. Cancel out moles again. My final answer, 11 grams of CO2. Looks pretty easy. Now let's try one involving grams of both the given and my desired quantity. So here's my equation again. And now my given information is 1.60 grams of hydrogen, and I'm looking for grams of ammonia. So my plan is going to be to go from grams of hydrogen to moles of hydrogen using its molar mass. When I get moles of hydrogen, I can then find moles of ammonia using the mole ratio from the equation. And once I have moles of ammonia, I can convert that to grams. Now I know it seems like a lot, but the most number of conversion factors you're going to have is 3. And we're going to see 3 of them here. So the first conversion factor is the molar mass of hydrogen. Second conversion factor is the mole ratio 3 moles to 2 that are from the equation. And the third conversion factor is the molar mass of ammonia. Well, let's set them all up. So I'm starting with 1.60 grams of hydrogen. You see how it'll cancel here. And then I'm going to figure out how many moles of ammonia I will get from my moles of hydrogen. And then I'm going to convert moles of ammonia to grams. My final answer, 9.10 grams. Now, it might look kind of complicated for you, but I'm sure others recognize this as the general way in which you solve stoichiometry problems. Here's one for you to try. So we want to pause the slides at this point in time. Here's the balance equation. We get larger formulas and larger coefficients from the equation, but I think you can do it. So give it a whirl, and then come on back and you can see the solution. Okay, here we go. Question, 52.9 grams of potassium chlorate. How many grams of tetraphosphorus decoxide can I make? So I'm going to go from grams of KClO3 to moles by using its molar mass. I'm going to use the balanced equation to go from moles of KClO3 to moles of P4O10. And then I'm going to go from moles of P4O10 to grams of P4O10. Again, 3 conversion factors. So let's line them up. Here's the molar mass of KClO3. Here's the mole ratio from the equation. So the 10 to 3. And that's why you'd have to have a balanced equation to do these. And lastly, here's the molar mass of P4O10. All right, go to set them up. My grams of KClO3 I'm starting with, I can cancel those out. Moles of KClO3 would go next. Moles of P4O10. And finally I get an answer of 36.7 grams. For those of you starting out, this might look like an awful lot to do. And you notice that it's not a formula, we're just plugging numbers in, we have to reason it out. And this is real problem solving. But I'm going to show you a simpler method. Now, even though we do the same things mathematically, this is going to look a lot simpler. Here's the same question that we just did a moment ago. So we're given 52.9 grams of KClO3, and we want grams of P4O10. So I'm going to say that if I can just find one conversion factor to solve this, I'll be home free. Well, where am I going to get the conversion factor from? Well, we did this earlier in this session. You know that if I look at the equation, this tells me 10 KClO3 to 3 P4O10. Well, I can interpret that 10 as 10 moles of KClO3 and 3 moles of P4O10. And once I say moles, I can go from moles to grams. So I can get my conversion factor amounts by taking the 10 and multiplying it by the molar mass. Taking the 3 and multiplying it by its molar mass. And here we go. Now I left the 3 and the 10 like that. I didn't bother distributing them across, so you can see where the numbers came from. So this is what I'm starting with. You notice that'll cancel out, and I get the exact same answer. I know the solution looks a lot simpler. Mathematically, we still did the same things. This is the way I like to do it. Now, you don't have to do it this way. You can do it the same way that you see it in the book. And this is one that we did earlier. I just wanted you to see the final answer. You notice how we got 9.10 grams, and we used 3 conversion factors to do it. Simplified, it would look like this. Here's that same question, 1.60 grams. How many grams of ammonia? Okay, I know I need my conversion factor. So for hydrogen, I'm going to multiply 3 times the molar mass. That'll go down here. And for the ammonia, it's 2 times its molar mass. And so the solution then looks like that. And you notice that we get the exact same answer. Now here's another question that we can try. How many grams of ammonia can be produced by reacting 38 grams of nitrogen? Here's my question. Let's see if you can solve this either way, either the longer method or the shorter method. So you might want to pause at this point and give it a whirl. If you're still not sure, you can follow my solution through it. Okay, so first step, plan it out. You notice I'm going to do the long method this time. My grams of hydrogen to moles of hydrogen using the molar mass. Moles of hydrogen to moles of ammonia using my 3:2 mole ratio. And then moles of ammonia to grams of ammonia. So I'm starting with that, and I'm going to draw the lines this time. Here's my grams of hydrogen. 1 mole of hydrogen is 2 grams. Cancel that out. Okay, so that'll give me then moles of hydrogen. Now I'm going to go from moles of hydrogen to moles of ammonia. Here's my mole ratio from the equation. You notice the 2 to 3 mole ratio. And my last one is going to be the molar mass of ammonia. Cancel out that. And I get 215 grams of ammonia. Simplified, what would the question look like? Here's the equation. Here's the same question again. I just note that one conversion factor. So for grams of H2, I'm going to have 3 times the molar mass. That'll go down here. For grams of ammonia, 2 times the molar mass. That'll go right here. There we go. See how the grams will cancel? Always check your solution by canceling out the unit and the formula. So if you want to get these wrong, just leave out the units and the formula sometimes, especially the unit, because it can be moles or grams. So be careful with these. Now here is one that we saw earlier where we had, for instance, a mixture of moles and grams, and we went through the whole process here of our 2 conversion factors, and here was the answer. Now the reason I'm bringing this up again is I want you to see the simplified method will work fine with this. Here's the equation. Here's the question. So moles of one substance, grams of another. I just need my conversion factor. Now this time, moles of nitrogen is just going to be 1. That's what I see here, just 1 mole. But the grams of ammonia would be 2 times the molar mass. And there we go. So we can have a mixture of moles and grams. There's no problem with this. Same answer, you notice. Looks awful easy, doesn't it? Alright, so here are 2 for you to try. So you want to copy these down, pause, I'll come back later on and check out the solutions to them. Now my solutions, I'm just going to show you the simplified version. So when you're ready, just click ahead. So the answer to the first one, you see it here. And for the second one, here we go. Here's one more for you to try. Here's the balanced equation. You always need a balanced equation. So here's the solution. Let me cancel that out.